Hello everyone, and thanks for watching Edupedia World Videos. In this video, I will show you the solutions to the physics questions of Paper 2 of JEE Advanced 2015. I will solve the problems as Okay, the next question is quite easy. We are given a circuit. I'm just going to draw the circuit. This is supposed to be a battery. So this is the bigger one here. So this is 6 volts, 6.5 volts battery. Then we get one resistance. Then we get another resistance. Then we get a resistance here. Then we get resistance here, and we've gotten two resistances here. We've got a resistance here, and a resistance here. Sorry, there are two resistances here. Right, you get the point. This is 2 ohms. This is 1, 2, 4, 8, 6, 10, 12 and 4. And we want to find the current through the resistor of resistance 2 ohm. So first of all, let's look at these 4. 2 times 2 is 4 and 1 times 4 is 4. So this is a Wheatstone bridge. So for a Wheatstone bridge, we know we can just remove the inner one. Right, because this will divide it into the ratio 1:2, this is divided in the ratio 1:2, so these two will have the same potential, so there will be no current passing through this. Now 1 and 2 together give me a resistance of 3 ohms, and 2 and 4 together give me a resistance of 6 ohms, and these two combined resistances are in parallel. So 3 and 6 together will give me a resistance of 2 ohms. So I can just remove this completely. And instead here all I have is a resistance of 2 ohms. Right. Now this is just drawn to slightly mislead you. This might as well be drawn like this. Right, it doesn't really matter because this had no resistance. Now 2 times 12 is 24, 6 times 4 is 24. So again this is a Wheatstone bridge. So again we can remove the inner 10 ohms. Now 2 plus 4 is 6 and 6 plus 12 is 18. So the new resistance will be the inverse of 1 by 6 plus 1 by 18. 1 by 6 is 3 by 18. 1 by 18 is 4 by 18. 18 by 4 is 4.5. So these together have a resistance equal to 4.5 ohms. And now these two are in series, so the total resistance is 6.5 ohms. The voltage is 6.5. So we get the total current flowing through this particular thing is 1 ampere. Now the current flowing through the individual arms might be different, but the current flowing through the 2 ohm resistance will be the total current. It starts getting divided from this point onwards. So the answer in this case will be 1 ampere. Let's look at the next question. In the next question, we are given that an electron in an excited state of lithium has angular momentum 3h by 2 pi. We know that the MVR, which is the angular momentum, is nh by 2 pi according to Bohr's quantization rules, which means the orbital is n is equal to 3. Now we want to find the de Broglie wavelength. De Broglie wavelength lambda is given by h by mv, right? So from this equation we can see h by mv is 2 pi r by n, right? But we know the value of r. According to Bohr's quantization rules, r is given as a0 times n squared by z, where n is the orbital number and a0 is the Bohr radius. So in this case r will simply be 3 square, that is 9 into a0 by 3, because the atomic number of lithium plus 2 is 3, hydrogen, helium and lithium. So this becomes 3, so it is equal to 6 divided by n, 6 divided by n, pi a0, and we know n is equal to 3 from here. So 6 by 3, so this is equal to 2 pi a naught, which is given to us to be p pi a naught. So the answer to this question is p is equal to 2. Let's look at the next question. Now this is a slightly tricky question. This question does have some concepts involved in this. So we have two liquids, L1 and L2, and we have two objects attached by a string P and Q. And we are given that the radii are equal and the densities are ρ1 and ρ2. And so the densities of this is ρ1, ρ2. The densities of the liquids are sigma 1, sigma 2. And the viscosities are eta 1 and eta 2. And they are floating in equilibrium with P in the first liquid and Q in the second liquid. Then we are given that the sphere P in L2 has a terminal velocity Vp and Q in L1 has a terminal velocity Vq. So first of all, let us calculate what the terminal velocity is. So if P is kept in L2, that means P will experience a force of buoyancy upwards, and it will experience a gravitational force downwards, and it will experience a drag force. Now P is lighter than L1, that's why it is floating, and L1 is lighter than L2, that's why it's up. So P is definitely lighter than L2. That means P will end up going upwards, right? So the equation for P will be 6 pi eta Rv will be 4 by 3 pi r cube times sigma 2 minus ρ1, because sigma 2 will be the corresponding to the buoyant force upwards, which will be more than the force due to gravity downwards. So the viscosity will be downwards, and this will be equal to this. And from this we can get the terminal velocity. That is, these are results you should probably know as well. It is 2r squared by 9. This is eta 2 because we are calculating for 2. So 2r squared by 9 eta 2 times sigma 2 minus ρ1 upwards. This is Vp. Similarly, Vq will be 2r squared by 9 eta 1 in this case, ρ2 minus sigma 1. And this will be downwards. Why? Because Q is even heavier than L2. Remember, if there was no tension in the string, Q would go downwards. Because there is a tension, Q is staying afloat. So the first equation we can see is option D. Option D says that their dot product is less than 0, which is true because they are in opposite directions. Then we want to find the ratio of magnitudes of them. So for that we can do something easy. We can take them both as a system. If we take them combined as a system, then the tension becomes an internal force, right? And since they are floating, the net buoyant force will be equal to the net gravitational force. So the equation will be V times ρ1 plus ρ2g is equal to V times sigma 1 plus sigma 2g. The total buoyant force is equal to the total gravitational force. From this equation I get sigma 2 minus ρ1 is equal to ρ2 minus sigma 1. And this equation means these two terms are equivalent. If those two terms are equivalent, then mod of Vp by mod of Vq will simply be eta 1 by eta 2. Because these two terms are the same, we are talking about magnitudes, not the direction. 2r squared by eta is completely same, so it will be eta 1 by eta 2. So the answer to this question will be option A and option D. The first option is correct, and so is the third option. So let's look at the next question. The next question is quite easy. It is related to dimensional analysis, right? So we are given the potential difference, electric current, permittivity, permeability, and the speed of light, and we want to find out which equations are dimensionally correct. So there are an infinite number of ways to do these questions. I just like to start out by simple problems which I already know the formulas for. So let's look at option A. Option A says that mu naught I squared is equal to epsilon naught V squared. I'll just try to simplify it a little bit further. We know that mu naught epsilon naught is 1 by c square. So mu naught is 1 by c square epsilon naught. So this gives me I naught. So this gives me I squared by c square is equal to epsilon naught squared v squared, which gives, these are all dimensional equations by the way. So which gives me I is equal to c epsilon naught v. Right. V by I is r. So we get r is equal to 1 by c epsilon naught. Now we can, I'm just going to write the dimensions for all of them and try to find the answer. So r can be given as energy divided by I square, because we know that I square r has the dimensions of energy, right? So r is energy by I square. Energy is force multiplied by distance divided by I square. I squared will be, q squared by t squared, right? We want to find if this is equal to 1 by c epsilon naught. 1 by c will be meters per second, so basically r by t, and epsilon naught we can get from the standard equation. F is equal to 1 by 4 pi epsilon naught q squared by r squared, which gives me epsilon naught is equal to q squared by r squared by f, right? So f cancel, we r squared cancel, and hang on, I'm making some mistake here. Oh yeah, energy is not I square r, power is I square r, energy is I square r t. So there will be divided by another t here. Yeah, so that was a mistake I was making. So this cancels with, we see that this equation is essentially correct, and so option A is correct. If option A is correct, option B has to be wrong, because we know that V and I don't have the same dimensions. Let's look at one of option C and D. So let's start with option C. In option C, we are given I is equal to epsilon naught CV, right? So that means I can be written as q by t is equal to epsilon naught. Epsilon naught can be written as q squared by r squared f into v into c first of all. So c will be r by t multiplied by v, potential. Potential will be f dot r, energy, by q. I apologize for the space there. So q by q square will be q and q will cancel, t and t will cancel, f and f will cancel, r square and this will cancel. So equation C is indeed correct. And if equation C is correct, equation D has to be wrong. So the answer to this question will be option A and C. Again, you did not have to particularly start with these equations. You could have started with any equations you wanted, and as long as you don't make any errors, you will get the final answer. Thank you.